Okay, in this next lecture video, we're going to go into a really important concept that you probably learned about over your years in science class, and that is something called homeostasis. Now, we have a very delicate balance of circumstances that exist in this thing we call a human body, right? We have all these moving parts, and we've spent the first couple of days talking about the idea that we're a machine. And in order to have a machine run well, it needs to be kept maintained, right? Perfect example is your car. One of the things you have to do with your car is you have to change the oil on a regular basis. And it might seem like, hey, why do I need to spend the money on changing my oil? Well, it's because if you don't change the oil, the engine's going to seize up. It needs to be lubricated, right? So there's certain things you need to do to keep your car running well. Well, that's how our body works as well. And there's a set of internal circumstances, okay, that you need to maintain in order to keep your body going. So let's talk a little bit about that. So what is homeostasis? Well, let's first talk about just the definition. It's very simply the maintenance of a stable, balanced internal environment. You can't control your external environment. Your external environment is going to change and you have to be able to react to it. So how do we do that? Well, we do that with this process called homeostasis, and every single homeostatic mechanism in your body has three major parts, and they're called homeostatic mechanisms. So I want to just explain that to you. And I'm going to try to draw a little bit, so let's see if that works. I don't know. I'm not expecting it to go that great, but we're going to try it. Okay, so first off, there's three parts to every homeostatic mechanism. The first thing you need to do is you need to know what's happening in the world around you, right? Your body can't react to the external environment if it doesn't know what's going on. And the only way we have to interact with our internal environment is through our senses. And we have five major senses, like we know, but our brain is registering a lot that's going on in the environment around us, and it has to be able to react. So the first thing we have is something called a receptor. So a receptor provides information about the stimulus that's in the environment. So, for example, your skin is a great receptor. If the temperature drops too low, that's going to be registered by your skin temp. If it goes too high, that's going to be registered by your skin temp. Your blood sugar, we're going to talk about that. That is registered by something called your hypothalamus, which we're going to talk about. So we have all these different mechanisms that help your body know what's happening in the world around it so it can react. The second part of every homeostatic mechanism is a control center, and that is the thing that lets you know where you should be. So what does that mean? It's something called a set point. So it tells you what that value should be. For example, the human body temperature, and I need to update this slide because we're going to talk about this a little bit more as the year goes on, but 98.6 degrees is the average body temperature of a human being. Now, that doesn't mean that if everybody that's sitting here right now took their body temperature, it would be 98.6 degrees. And in actuality, that temperature is dropping over time. It's less than it used to be. And there's a lot of people that theorize a lot of different reasons for that. And hopefully we'll get to discuss that in class as we go through. There's also a set amount of blood sugar you need. There's a set amount of sleep you need to have. There's a set amount of proteins you need in your blood. So there's all these different set points that is controlled by something called the control center. And in human beings, our main control center is a part of the brain called the hypothalamus, and we'll talk more about that. And then finally, we have our effector, and the effector elicits a response that changes the conditions in the internal environment to be what they need to be. So I'm going to use an example that we could all probably relate to on a certain level, and that is going to be a thermostat. So I'm going to try out, I got this new tablet here, and I'll be honest, I'm still getting the hang of it, so this is going to be pretty messy, but I'm going to give it a shot. So a thermostat is a pretty simple device, and if you look around your house, chances are you'll find on the wall somewhere probably near the kitchen or the living room a little box, and there's a digital, or it might not be digital, but you can set a temperature. So I grew up in a house, and my dad, when I was growing up, was, I'm going to use the term frugal, and they would keep the temperature way too low in the winter and way too high in the summer. So I was always hot or cold. So as an adult, I've decided to set the temperature I like. So let's say I love 72 degrees. So 72 degrees is the temperature at which I want to keep my house. That is going to be the set point. So again, you can see it's a little messy here, but that is going to be the control center. So I just talked about the fact that there's three components to every homeostatic mechanism. The control center is going to be in this case, it's going to be the thermostat, but in our bodies, it's the hypothalamus. And we set that temperature. Now, you don't set your internal body temperature. That is set by nature and evolution, but we'll get to that later. So how does your thermostat know what the temperature is? Well, if you were to look around your house, somewhere there's going to be a little vent up near the ceiling. And it's not actually a vent like the rest of the house that pumps air out. It's called a return. And what it does is air goes in from around the house, and that it travels through some vents to where your unit is, your heating and air conditioning unit, and that sends information to the thermostat. So for example, let's say the temperature drops down to 70 degrees. Okay, that is going to be our receptor. So the receptor is taking information from the outside environment and sending it to the control center where it's interpreted. So this little digital device here is able to say, hey, this is cold, so it needs to react. And it's going to react by turning on the heat, right? So the heat in this case is going to be a blower that heats up. You have somewhere in your basement, you have a heater, and that is going to send warm air out into the house to heat it back up again. And if it gets back to 72 degrees, which is where it's supposed to be, this shuts off, and that lets it know it, and then we are in a good place. So that is a perfect example of not your body, but just something in your house that is an exact homeostatic mechanism. So homeostatic mechanisms, there's two possibilities for them. They could be negative feedback or they could be positive feedback. So I'm going to finish up this lecture by just comparing those two scenarios. So first off, negative feedback. The term negative feedback is a lot of times misunderstood. Negative doesn't mean bad. It just means opposite. So I'm going to explain what I mean by that. So most processes in your body, most homeostatic processes, in fact, almost all of them are going to be a negative feedback scenario. What does that mean? Well, I'm going to give you an example. I'm going to go back to that little chart here. I know a lot of you probably care about your grades, and that's a good thing, right? So let's say you are a student that normally gets 90s on tests, right? And things start to go a little haywire, your life gets a little crazy, and over the next couple weeks, you start to notice your grades are going down, 80, 78. What you will probably do if you're a conscientious student is you will figure out what's going wrong, and you will then do what you need to do to get your grades back up again. That is negative feedback. Even though it's going back up to where it was, it's still negative feedback. Negative feedback means it goes in the opposite direction of the change. So, for example, if my temperature is set at 72 degrees and it goes down to 70 degrees, my body's going to bring it back up to where it needs to be, or my thermostat, whatever example we're doing. Even though it's going back up, that's negative feedback. If it goes up, let's say, to 74 degrees, it's going to come back down to 72. Those are both examples of negative feedback. Even though they go opposite directions, they always return back to the set point. So the trick with negative feedback is it always returns back to the original set point. Okay. Examples would be blood pressure, right? If your blood pressure goes up, your body will respond to get it back to where it needs to be. If your body temperature goes up, if your glucose level goes up or down, if your blood sugar is too high or too low, you're going to release some hormones called insulin and glucagon, which we're going to talk about a little later, that gets you back to where you need to go. So that is a negative feedback mechanism. And again, just to clarify, almost all of your homeostatic processes in your body are negative feedback mechanisms. Okay, I'm going to skip through these examples and we'll go over them later because I just want to explain what positive feedback is, and then we'll come back to those other examples. So positive feedback is an example that is a little strange, that most of our processes are not positive feedback. In fact, there's only a few that work that way. So what is positive feedback? Again, it has nothing to do with good versus bad. Positive and negative in this instance just means which direction the change occurs in. If it's negative feedback, it goes back to the set point. In positive feedback, it changes and then continues to change in that same direction. So what do I mean by that? Well, I'm going to give you some examples. One would be blood clotting. Another would be breastfeeding and childbirth. And we're going to go over some of these examples, but I'm going to use another example, which I think is a good one, which will hopefully help you to understand. So in a normal circumstance, without a fever, what happens is you have your body temperature, 98.6 degrees, right? And let's say you're working out or something, or it's hot in the room, your temperature goes up. or it's really cold and your temperature goes down, what happens in a normal scenario when your body is functioning, in a normal situation, the temperature is going to come back to that set point. That's negative feedback, right? So we talked about that already. But let's talk about another scenario. Let's say you're sick and you have some bacteria in your system that you're trying to fight off. Your body temperature will go up. But then instead of coming back down again, it continues to go up away from the set point. That is called positive feedback, okay? Because it's not returning to the normal situation. So that's just one example of positive feedback. Another example would be, like I said, would be breastfeeding. When a baby is breastfeeding, that triggers the mother to produce more milk. If a baby stops breastfeeding, the mother will stop lactating. So that's a positive feedback scenario. Another example is oxytocin with childbirth. When a woman's giving birth, that triggers more contractions, and more contractions trigger more contractions. So the point I'm making here is positive feedback only occurs in specific instances. Normal conditions is going to be negative feedback. That's enough for today's lesson. I'm going to go further into some of this stuff, but for today, this seems like a good stopping point for this lecture. Thank you very much and have a great day.